Alrighty. All right, so I guess we'll go ahead and get started. If you have questions at any time, please let me know. Just put them in the chat or shout them out. I have a bunch of questions also, just kind of like review questions. You can answer or try answering if you want, or if not, we just go over them. Um, all right. So module one, that was basically the lower layers of the OSI model, the introduction of UDP and TCP, and kind of the basics of network addresses and how they work. Um, the OSI layer, this class is actually pretty good on concepts and it doesn't have a tremendous amount of memorization, or at least that was my experience. So you do get a card that you can write down notes on for the test. One thing that's not a bad idea to throw on there, unless you're very confident, it's kind of like a bullet point summary of, you know, if you get asked a question like what layer typically handles component to component transmission, you would want to know like, hey, that's probably the data link layer. Or, when do we start caring about IP addresses? That would be the network layer. So this would be a really good thing to jot down. Um, Excuse
Don't
me.
we get a sheet of paper, not a note card?
I gotta be honest, I don't remember the size. If it's a sheet of paper, that's awesome. Some of them just say like a 3x5 note card. I know that you get a thing for notes. I just don't remember the size if it's mentioned.
The testing page does say that it is a full page for us.
Oh, fantastic. Okay. Um, so does anyone have any questions about the lower layers or what anything does there?
I don't think so. Will you be sharing these slides as well?
I can, absolutely.
Okay.
They're fairly simplistic. It was just meant to be like a collage of ideas that kind of remind you like, hey, do I feel like just looking at this like, oh, TCP, oh shoot, am I prepared to answer a question about TCP, for example, that kind of thing, without like giving you all the information on one slide. So they may not be super helpful, but I can certainly upload them.
Do you have like any questions or things to ask us?
Yeah, I have a few questions.
Okay.
Um, like for example, does anyone know what the transport layer is responsible for?
That is sitting um it like that's the carrier, mail carrier.
Yep. It's the first one where you're using protocols like TCP and UDP, really. We care about what kind of data we're sending. As for that, do you remember the difference between UDP and TCP?
TCP you care about what's being delivered. UDP you can't. UDP is faster. TCP is slower. Um,
Perfect. Yeah, that's exactly right. TCP tries to establish, it has a three-way handshake. That's where it starts to say, hey, we're talking to each other. We've established we have two-way communication. Fantastic. Now we can talk. That's a connection-oriented protocol, whereas UDP would be connectionless. So TCP would be, so let's say you wanted to make a chat application like Facebook Messenger. Which do you have which one would you prefer to use?
can you repeat the question?
If you were developing something similar to Facebook Messenger, like you were wanted to have two-way communication or group messaging or that kind of thing, which protocol?
TCP.
Exactly. Yeah. Okay. So that's fairly straightforward, but yeah, just understanding the different scenario between the two of them, and then I think it'll come up. in a later slide, but just you don't have to have this memorized. But let's see if I can. The general gist of the headers, just know that the UDP header is much smaller because there's less data, and that translates to less overhead and faster transmission speed, where TCP has a lot more security, but also more overhead. So,
I did have a question. So if you're saying like for chat messaging where you're talking to one person, like TCP would be like your better option for like if you're doing like a messenger app. But like when would you want to do UDP instead?
so yeah, TCP comes with a lot of reliability. UDP, according to the,
I
uh,
actually
oh, sorry, go ahead.
I, sorry, I didn't mean to interrupt. I was saying I remember reading about a really good example for UDP where it's where you care about the speed of the delivery over everything else. So something like video games and stuff where you want everything to be responsive and you don't really care if maybe packets come in out of order and there's a little bit of screen tearing as long as things are for the most part super responsive.
Yep, that's exactly the example I was about to bring up. That's what the material says. I don't know about you. I kind of feel like if I swing a sword at an enemy in a video game, I care about it hitting, but I'm sure that's a great example of it for sure. For this address here, this IP address, hopefully everyone's kind of able to identify which part is the IP address and which part is the port. Like what would be the port in this IP address?
Um, 8080.
Exactly. It's fairly so. We've been doing this for like 7 weeks at this point. Just had to double check. All right. Honestly, module one was a fairly light module. UDP and TCP will come up again in, I think, module three. But did anyone have any questions on anything here?
I don't. Was one stateful and one stateless?
One is TCP is connection oriented and UDP is connectionless. Neither of them really, I would say they're both stateless because they're both
Okay.
sending a message and they don't really care what came before. Yeah. The stateless versus stateful is mostly based on like HTTP protocol kind of thing where you care about what happened before. I mean, that would be stateless, and you'd use things like cookies or other kind of like extensions to maintain understanding of what happened in the past.
Yeah, the stateful and stateless are what I have trouble with, and I couldn't remember what it was on.
Yeah, the easiest way I think to remember that is just, hey, does this action that we're doing care about anything in the past, or does it rely on that? So like a secure connection, like HTTPS using either SSL or TSL, those care about, authenticating and then keeping track of who's authenticated so you don't have to log in over and over. That would be like a stateful thing. But
Hmm.
many communications are stateless because it's just simpler. All right. Uh, Move on. See what's in module two. We have the upper layers here. Thank you for writing the notes, by the way. I didn't
Yeah.
it didn't realize it translated between slides, but that makes sense. So here we have the upper layers. This is kind of where we're getting more into what we code as programmers in Java or anything else. Obviously, the application layer is the highest layer. That's where you're going to be programming your protocols or using RPC, that kind of thing. Ooh, excuse me. Um, the presentation layer is more of the translating, compressing, encrypting. It's one of the layers that kind of gets abstracted away a little bit by using things like gRPC much, much later on. And then session layers for the authentication, authorization, session management, that kind of stuff. Um, for HTTP and HTTPS, what would be the difference between those?
HTTP is non-secure, HTTPS is secure.
Okay. And if I said TLS, do you know what TLS is?
Mm,
Even if you don't know what it stands for exactly.
no.
So TLS is one of the is the option that's primarily talked about in the course material for how the connection is actually secured. SSL is another one that's mentioned, but basically if you go to a website, you can look up at the top in the address bar and you'll either see a lock icon or a lock with a like a dash through it. I think it varies a little bit depending on which Internet Explorer you're using, but that's kind of a good way to know if your communication is secure or not. And I think it was, yeah, it was in this class where we used Wireshark. And you can
Yeah.
kind of see the difference of when you send HTTP messages versus HTTPS. You could see like, hey, I can see everything that's being sent versus, oh no, it's gibberish. So kind of a cool little thing. Thankfully, almost everything is HTTPS because it's just
Yeah,
smarter.
Google pretty much makes everything be HTTPS.
Yeah. Um, does anyone remember what SMTP or FTP are?
No.
So SMTP is a simple mail transfer protocol. Realistically, I don't think you have to like memorize the words so much as just know it's for mail. What makes that special is it's going to just send, it's where HTTP and HTTPS are kind of a pull protocols, as in you send a request for information like, hey, I want to go to this website, and the server sends you back, hey, here's the website. SMTP is kind of it's a push protocol. So it just pushes the mail out when it gets it. That's just how mail works with email, I should say specifically. Um, let's see.
Can you
Uh,
remind me which one was stateful and stateless, please?
yeah, HTTP and HTTPS are both stateless.
Okay.
The reason for that is every time you send a request for I want to go to a website, it doesn't care what website you're on. It'll just give you the new website, that kind of thing. That might be a good way to remember that one. Whereas the mail transfer protocol or the SMTP, that would be a stateful connection. I'm pretty sure, right? Let's see.
I'm looking through my notes. My note says that it is stateless.
Oh, yep, you're right. You're right. It is stateless. So stateful would be kind of when you go and you add like cookies or something else, it kind of makes it act like it's stateful without actually being stateful. A good example would be, let's say if you go to Amazon and you don't have a cookie, it'll just send you the Amazon main page. But if you have a cookie saying, "Hey, I'm this authorized user," then it could talk to your computer and be like, "Oh, we can just automatically log this person in." So yes, you're right. They're both stateless.
Okay.
And then FTP is barely talked about. I almost didn't mention it, but I don't know. There might be a question about it. I can't imagine there would be. It's a file transfer protocol, and it's between two computers. How it works specifically was mentioned very, very briefly, and I seriously doubt there'll be anything about that.
And my notes say that that one's stateful. FTP is.
I don't have that in my notes, so That's probably a good example of stateful then. Cool. Um, does anyone have any questions about the upper layers or the various transfer protocols we've talked about so far?
Well,
Like if I was to ask what the default port for HTTP or HTTPS is, would anyone know those?
port 43 for HTTP, HTTPS, I want to say I know has 3 digits, but I can't remember.
So what I'm tracking is HTTP has port 80 and
Oh, 80.
HTTPS has the 443.
Oh, okay.
Um, I did look up the ports for SMTP and STP, but I don't think they're actually in the material at all. They're very
Mhm.
convoluted. Like, for example, the mail one is technically 25, but apparently there's so much spam on that port on the internet in general, it's just mass blocked. And so 465 is the secure version, but none of that's from the course material. So I, yeah, there was pretty much just remember the 80 and the 443, and you'll probably be good to go.
And you may not know, but the reason that HTTP is like 80 and then the HTTPS is 443, isn't it because like HTTP came before HTTPS? And so it has like a lower number of a port number because they later like the ports get like
That's
used on.
probably right, but you're right. I don't know that one. Um, for status codes, this is another good one that might be something valuable to throw down on your notes, unless you just happen to have them memorized. Obviously 400 is the one that's just famous, 404 specifically, when the website just isn't available. Does anyone know one, two, or 300?
100 is info,
Yep,
200 is success, 300 is redirect, 400 is client error, 500 server error.
perfect. There's a link where you can get a lot more in detail, like, of 201, 202, 203, all that kind of stuff. Um, I wouldn't put a whole lot of effort into trying to memorize all those. There's quite a few. If as long as you know like one, two, three, 400, you'll probably be able to answer anything
And
going on with those.
500.
And 500, yes, you're right. Although I don't remember much talk in the curriculum about 500, but
It still could be a question like
you're
name
right. It
what the
could.
five are.
Yeah, absolutely. Does anyone remember what a DNS server does?
Basically like a phone book. Like it saves all those um all the numbers into like common names so that way you don't have to remember the full number for like a website that you want to go to.
Exactly. So basically, you would type in www.google.com. Obviously, the internet doesn't really care about Google. They want to translate that into something it understands. So it goes to a DNS server and comes back with the numbers. Exactly. How about get, post, put, and delete? Do you know
Um,
when those would be used or how they would be used?
Get is when you wanna receive something. Post is when you're I forget. Put is when you want to add something, and delete when you want to remove something.
Perfect. Post is when you want to send information out.
Okay.
And kind of bonus points, I left one off this list that I technically left a whole lot, but there's one talked about in the class. that's not on this list. Do you remember what that one is? It's barely mentioned.
You don't.
It's a patch. So patch is when you want to update a resource, but you only want to update some of the resource. So it updates part of it rather than replacing the whole thing. Um, I would be shocked if that was on the test, but nothing past these five should be on there anyway, because everything else is extremely unused.
What did you say post was again?
Post was submitting or creating data.
Okay.
And then last thing for module two, for this URL here, can everyone identify from this string right here the protocol, host name, path, and query?
Example is toast. Path is search.
Yep,
Query is this whole block here, the end.
yep. And
And then what was the first one?
the protocol. That one's the easy one. It's at
The
the
very
beginning.
beginning.
Yep, you got them all. Awesome. Does anyone have any other questions about module two?
So
Right.
on this URL, I mean, how do you know this is a get, but how do you know this?
I mean, I don't know if I understand correctly. In this one, your a search is you're looking for specific information or you're trying to get information.
Right, but I mean, if this was one of the other methods there, would it have to say post? Like, how would you do a post?
So the get, post, put, delete, that kind of stuff is going to be something that would be in the code, not in the URL itself. So this is something the programmer would have to set up because you would type it, you would go to example.com, and then based on how you interact with the website, the programmer will decide if you're trying to get, post, put, delete, that kind of thing.
Mhm.
But it's not really visible in the I forget what that's called, like URL
In the
block.
URL.
Yeah,
Well, I mean, the endpoint would be exposed, but I'm just curious, anything after the question mark is some sort of HTTP request.
yes,
And it could be one of those methods depending on how the programmer has
exactly.
implemented.
And the protocol for like how exactly it'll look will be entirely determined by how the programmers have implemented the website and the resources. I don't know a ton about web development, so there might be a better answer to your question. I just don't know.
No, that helps. Thanks.
Absolutely. All right, I'll move on to module three. At this point, there's going to be less and less topics per module, but usually they're a lot more in depth. Like module three for me is when things really started to get kind of crazy because we have sockets. So let's see. Here's a pretty good example of. So let me just do this. Um, so sockets obviously are how they're the endpoints of network communications. So a socket on any device that has an established connection will kind of be how you get information in and how you send information out. They connect on a port and IP address. And then a server obviously doesn't have to care. You see down the TCP server where it shows it doesn't have to care about the IP address because it's just where it's at. It just looks at the port and then has to establish connection. I think this code right here is probably an excellent example of the simplest, most streamlined demonstration of how this all functions. This was the crux of most of our assignments throughout this course.
Could you go back to the second screen?
Yeah. This one right here.
Yeah, I just was trying to get a screenshot.
Oh, sorry.
Thanks.
Absolutely. So for sockets, well, I mean, I guess that's pretty much sockets in a nutshell. We have the JSON protocols. Module 3 also talked about TCP and UDP. This is where I believe the headers were primarily talked about. Just put that briefly back on the screen. You can kind of see the difference. UDP is smaller, TCP is bigger. We kind of already talked about that. Client versus server. Obviously, that's the different methods of communication. Typically, in this class, the server has been sending out information and the client reacts. There's a lot of different variation in how that can work. There's push servers, there's pull servers, that kind of work how you'd expect. Either the server pushes out information or waits to get information from the clients, depending on what the actual application needs to do. Does anyone know when you would use a datagram versus a socket? These different collections of um, objects here in Java programming.
I don't recall seeing datagram.
It's mentioned very briefly, but it's for UDP. So actually, here's an example right here. As opposed to, you can see the TCP cares about um, getting in and out. For UDP, right here, all we really care about is we're getting our information, we're creating a packet. This is actually part of this line. Like this is all one line. It kind of looks a little funky how it got cut off, but it's basically just building a packet by plugging in the data, telling it its destination, and sends it off. Whereas the datagram socket is just creating a buffer, grabbing the packet, putting in the buffer, and the communication's done at that point. There's no need to concern itself with going with like two-way communication. So datagram socket and datagram packet are Java's default way of handling UDP. Darn, now I don't want to move this thing. Yeah, that's the one. And then TCP is much more involved. What I would expect to see on the test would be something like you might see this block here, and there might be a part missing, and it would say, hey, what goes here? And give you several options. So in general, you would want to at least understand the flow of how this goes. Like, the client needs to establish this. The client cares about the IP address and the port. You have the in and output streams, and then it can communicate out, or it could read in, and the TCP server uses server socket, and that once it has a connection, it can use that to create a socket object directly. So like client socket here. And then it basically does the same thing, gets the input output, and then they can talk until they close. So, excuse me. Oops. Stuck. Um, So when it comes to JSON protocols and how those get developed, there's not really a right way or a wrong way as long as it works. But one thing that's highlighted in the curriculum a lot, that would help is making sure you have um, sort of like a status field, something where you could be like, hey, is there an error, or is this a good happy day response, I think it's called, or is this a error response? That way you can kind of simplify your code for how you handle things. Actually, here's a JSON protocol right here. And it's very likely you'll have to, as at some part, probably at the end of the test, they'll probably give you a scenario, and you'll probably have to build a simple protocol that could handle it. You don't have to get crazy with it and do some enormous thing, but it should at least make sense. So for that, you'll definitely need the format like this. I know I wrote something like this down on a card just to give me the specific format for, this stuff's not too hard up here, but you have a list here, you have arrays. This kind of sums up all the Java syntax really nicely right here, I think. And then you would also want to include the response, which we can see down here. And then there's actually two more. I'm sorry about the notes. And then we
Okay.
have the two-way communication kind of thing. We can see the response, like a possible response. You most likely would have to give like an example error response also.
Like we've
But
been
it
doing in our homework.
exactly. Nothing new and probably a lot simpler than what's been in the homework, if I'm being perfectly honest. I remember after doing all the assignments in this class, the final test felt surprisingly easy because, well, the assignments are kind of a lot, or at least I thought they were. Let's see, we talked about client server push-pull protocols. Um, asked that already. We're going to talk about that in module 4. Um, what does it mean that socket.accept is a blocking call? Like, what is that functionally? What does that mean?
That is accepting that they have are connecting to the client.
Yeah, we see it
So
right here. So, yes. But what it also means is when the code execution gets down to this line right here,
so it's also a wait.
it's basically I'm waiting. So I'm not going to go past this line until I establish a connection. So it stops everything, which is usually a good thing because otherwise you would have to do this like while connection equals false thing and just run this line of code a zillion times. That would probably not be very good. But what this lets you do is this blocks everything. So this is where you could put this in a loop to connect a certain number of times. I mean, you guys have all done this in the assignments, but basically code won't go past here until something connects. This is the main gist. That's a huge focus of the videos in this module. So I could basically guarantee there'll be a question that requires you to understand blocking calls. There's really nothing too special about it. It's just can't go past until it gets what it wants, which in this case is a socket to the client. Does anyone have any questions about module 3 stuff?
I think so.
Only a few topics, but
Something
no-
that's a little confusing is just the terminology.
Hmm.
of the use of the word protocol. I mean, JSON to me is like a schema. It's for defining the schema, the data elements that the program's going to carry.
Hmm.
So I'm just like, I think of a protocol as like HTTP protocol or a transport protocol. So I'm just curious, what is the reason for calling it a protocol?
I gotta be honest, I don't have a good answer to that. I I'm using things like the terminology here. There might be a maybe schema is a better phrase. Schema does kind of make sense with me just thinking about it in the moment. I'm
Mhm.
just kind of reading off the slide
No,
from the
I know
class,
the
but like,
instructor, they do that in the class. It just was a little bit confusing to me to call it a protocol, but anyways.
yeah, I
I,
can
I
I'll write that down. I can ask the instructor. She might have a better answer.
I was going to say, I don't know if I would consider JSON itself a protocol. I mean, a protocol is just a rule for communication, right, between whatever you want. So you can certainly design at least from my understanding, is that you can certainly design a protocol using JSON. Um, but you'd probably, if you do the protocol through sockets, sockets use TCP. So I guess TCP would be the protocol that you also kind of make with JSON. That's
Mhm.
kind of like
Yeah,
my understanding of it.
that certainly sounds right. Like JSON, you're defining the protocol is maybe like, hey, there's going to be a type, there's going to be a request ID, there's going to be user ID,
Hmm.
whereas JSON could be the schema that's being used, whereas XML would be an alternative schema.
Right, exactly. Yeah.
Okay,
Anyway,
yeah,
when I was studying this, I just got to look. I wasn't used to the word protocol being used for in that way, but
it's certainly used a lot here.
yeah.
All right, let's see. For module four, this is a lot of the concurrency stuff. This can definitely get confusing, especially when we have this list of semaphore is there. All right, this list of like keywords that all kind of it's kind of hard to understand how they're all unique because they all kind of relate to each other. I remember that being very confusing. Does anyone know the difference between race condition, deadlocking, and starvation?
Race condition is trying to get its work in. Deadlock is when nobody will ever be able to finish, and starvation is when one mutex doesn't get to ever complete its work or get a chance to do its work.
That's pretty good. The only small difference I would say is race conditions is it's kind of a broad term. Technically, it also includes scenarios where multiple threads or processes are going for a single resource, and we can't know which one will get there first. So there's not a deterministic way of knowing what code will execute first, which could cause very strange errors. Deadlocking, exactly right. It also could be when there are multiple, like you need multiple resources to do one thing, and you can get one of the resources, but you can't get the other. And maybe another thread's trying to do the same thing. It needs two resources, but each has one, each is looking for the other, and no one can move forward. And starvation is, yeah, no CPU time to execute whatsoever. All of them are very bad. Race condition is kind of the most insidious because it'll usually run, but it can be unclear why there's an error. That's why a big part of this module is like mentioning that troubleshooting these kinds of problems is very challenging. Actually, we have our terminology down here for XML, JSON. My goodness. Does anyone, is everyone familiar with like what these items would be, or maybe more importantly, what the difference, what XML and JSON have in common, and what Java object binary and a protocol buffer have in common?
Um,
XML and go ahead.
I was just going to say that XML and JSON are meant to be human readable, and the other two, they kind of serialize the data into binary, so you can't really read any of the data that's sent.
Absolutely. It's far more efficient to send binary, but it's a lot harder to read for us for sure. The only thing I would say is you can technically serialize any of this information. It's just XML and JSON will be characters as opposed to binary, so it's slower and you'd probably have to send a lot more packets. There's just more overhead, but exactly, yep. What about the difference between a process and a thread?
Um, a thread I know is it like creates its own line of like work.
Yep. So it has to do with state or memory primarily.
Okay.
So I think a process is like a whole new instance of your program. So it kind of has its own memory. And I think it has a lot more overhead because of it. And thread, it's kind of like another running instance of your current program that shares the memory with other threads.
Correct, except for I don't know if I'd call it another instance of the program so much as it belongs to a process. So a process
Yes.
could give it as much or as little latitude as it wants, really. But it's going to share, it's going to use the state and basically the memory of the process that spawned it. So much, much, much less overhead. Usually you could have enormous numbers of threads, but you probably don't want an enormous number of processes running because, as you mentioned, the overhead. Exactly.
So the process has less overhead.
No, a process has more, a lot
Okay,
more.
that's
So, like for example, we're looking at Zoom right now. Zoom would be a process, but there's probably, and I'm just guessing because I have no idea, there's probably a thread that's handling the UI. There's probably a thread that's handling displaying the image that's being transmitted. There's probably other threads in the background that might be reading and writing data to memory, that kind of thing. So one process is usually going to have multiple threads, and then the CPU will go between the threads, try and give them all time. It's kind of a good way to think about it is if you have an app that needs to do a lot of processing, like let Windows Explorer, let's use that as a great example. Let's say you're trying to transfer a large number of files. You don't want to not be able to click on anything while that's in progress. So you'd have a thread working on transferring the files, and another thread could handle the UI, and it basically makes it feel like you're doing many things at once.
so process uses more memory.
Absolutely. The thread uses the process's memory. It uses more overhead, I should say, because a process is a
Okay.
big thing, like a application, whereas a thread is just one small part of an application.
Thread shares memory from process.
Yes, yes. It shares resources, memory, state. Oops, sorry. I think that's pretty much all kind of the same thing. But yep. Now here's the messy one. How how does everyone feel about these terms on the screen? These
Locks and
locks?
mutex.
Yeah.
So the lock is it's like the type of lock that you need a key for, and the music mutex is like the key enters or the key exits.
Uh, I kind of see it as I think they're basically the same thing. I think it's a mutex and then it locks. I
Yeah.
know the phraseology is used kind of back and forth, but like you would actually type in mutex, lock and unlock kind of thing into Java. Oh, we have
Yeah, that's why I
someone's.
was thinking the mutex was the key to unlock and lock the.
Yep.
I think those specifically, the semaphore and the spin lock, they're like more of the lower level thread synchronization tools.
Yep. Semaphore is going to so they both basically do the same thing, but a semaphore is is the one where you can say, "Hey, I want to give access to 5 threads at a time or 2 threads at a time to this resource." And one will go into a block of execution, and that kind of uses a hall pass. I forget the terminology used in the class, to be honest, but let's say you initialize a semaphore with 2 hall passes. One goes in, they use up one, another goes in, uses up that one. No more threads or processes can go in there. The threads would be realistic. No more threads can go in there until one of the resources is unlocked. So basically, you would the exact keyword I believe is acquire and then release. So you would release a semaphore to mean another thread could use that resource. I don't actually have a code example of this handy. Um, but basically the difference between a semaphore and a spin lock is just the semaphore sits there and kind of waits. It's a blocking call. It doesn't keep executing, whereas a spin lock will just keep checking if something is free, if that makes any sense. They're very, very similar. It's just the implementation works a little bit different. And then I'll, this is kind of where things get kind of confusing, at least to me, is because the mutex or the lock is it controls access to shared data, but the monitor is an object level lock. They primarily, effectively, they seem like they do pretty much the same thing. And if you use the synchronized keyword, depending on how you use it, it uses either a mutex or a monitor in the background. Honestly, the most important thing I think to remember is just it kind of locks a block of code and has to be released before you can get in there again. And if you use synchronized, it uses those in the background so you don't have to care about the details so much. It'll just a code block that is synchronized or a method that's synchronized, only one thread can use it at a time, which makes it very, very valuable.
Definitely been using a lot of those.
Absolutely. And what a cool thing that I didn't realize until the end of the class was you don't need to just do synchronized on a method. You could do synchronized on just a block of code. And I think it even talks, I don't remember if this is in this class or if it's in 334, but a big focus, probably in both, honestly, is how you want to have as little code as possible synchronized because you want to have it locked to a thread for as little time as possible.
Mhm. They do mention it here is that the more synchronized code blocks that you put in your code, the lower your code throughput will be.
Awesome. Now, what about atomic and volatile? Does anyone remember what those do?
Atomic, I don't.
So
Atomic,
I'm
atomic
sorry, go ahead.
means uh, it's all or nothing. Everything succeeds or nothing succeeds.
Pretty much. So when you're reading data from memory under normal circumstances, you're kind of it's usually several operations. You're reading the data, you're updating the data, and then you're writing it back to where it was. So if one thread reads data, basically copies it into a buffer somewhere, like, hey, this number is 4, and then another thread jumps in and reads the 4, updates it to a 6, and writes 6 in there. Like basically threads could interrupt that process, whereas atomic will force the read, update, and write all to be one action. So you get exactly what you said. You get all or nothing. You wouldn't have updates getting interrupted by what's effectively a race condition.
From my understanding of atomic is that you can pretty much call atomic operations as much as you want without ever having to worry about any kind of issues with the threads.
Yeah, it's extremely useful. And in a lot of, if you happen to poke around in like really good code on bigger projects or something, I swear everything's atomic. It's a lot. It's a very popular one. And then volatile is very similar. I've actually never used this, I don't think, but it basically ensures that changes to a shared variable across threads are immediately visible. So basically, sometimes threads have local copies that they use of variables that let them access it faster. Making something volatile basically means that if a thread updates a value, or if anything updates a value in one place, everywhere gets that updated value immediately, and there's not going to be 6 versions of one variable that different threads are tracking. So many things for notes on the screen.
Yeah. Sorry, they're kind of all over.
It's better than the notes I wrote, so. Does anyone have any questions on any of these topics? I'd say the biggest things to remember is use synchronized everywhere. Process is big, thread is small and agile. Serialization is the process of converting data as needed to send over a network. And then the difference between race condition, deadlock, and starvation, you're basically guaranteed to have a question asking about distinctions between those 3.
I mean, serialization is a little bit confusing because, like, like when do you need to serialize something? If it's an object, right?
Yeah. So anytime you need to take data and send it somewhere. So if you're if
But
you're taking a class, if you want to take a class state in a program just on your computer and you want to save it to a file, you would want either you need some kind of format to save it into so you can read it out properly. Kind of the same way when you send the information over a network, you want to know, you want kind of I hesitate to use the word protocol, but you want a schema maybe for how is this going to show up so that the other person can read it. Like a Java object binary, you convert a Java object into a Java object in binary. So when it's read either from a file or over a network, you know that it was created, the data was serialized in this way. So you know exactly how to get useful information out of it, if that makes sense.
And I forgot what the serialization you said was for.
The what? I'm sorry?
What was the serialization for? I forgot what you said.
Converting data as needed. So you can
For what?
read what you write, basically.
Okay.
So
So
we're, I'm sorry, go ahead, Tim.
I was going to say that the definition that I have in my notes is just translating data structures or object states for storage or transmission. So yeah, basically just preparing the data to be sent.
Yeah, that
Okay.
definitely sounds better.
yeah, but so this is confusing because what why don't I have to serialize everything that I send over the wire?
You do.
But
Everything is serialized. That's why in all of the lessons we've either been sending, we started out sending just like I think we started by sending out strings, probably was in the first assignment, um, which would have gone over as characters or binary. I don't remember what the first assignment had exactly. Later on, we use JSON, which is basically we take data, we structure it into a file, a .json file, which is human readable, but still structured in the sense that there's formatting and you can know like, hey, there's a key, then a value, a key, then a value, that kind of thing. And then
Mhm.
that gets sent over the wire, and then the reader knows, hey, this data I'm getting, this was serialized with JSON, so I can convert it back from whatever bits and bytes it actually shows up in into a JSON file properly, and then we can read it with a JSON parser or whatever we have set up.
Mhm. But some programs, I can write a basic program. I don't have to serialize it.
When would you not? So, like, if you're communicating between the program and itself,
So okay, so this is, I don't know though. So this is the question. So
mhm,
anytime you send something over a network, a distributed environment, you have to serialize it. Is that the gist?
as far as I understand, yes. I
Okay.
can't imagine a scenario where you wouldn't need to. Technically, anytime you save a file, you're also, in a sense, serializing it. Probably you have to serialize. I think the term could even be expanded so that anytime data is leaving your application and later needs to be interpreted by anything, that's probably the serialization.
Mm.
And that's why you'd have various um, schemas and protocols of how to do it, such as XML, JSON, Java Object Binary, and Protocol Buffer would be, I guess, based on our earlier conversation, would be schema, and the protocol would be like, let me pull this over here. Oh gosh, would be, hey, we know there's going to be a type object, there's going to be a request ID, there's going to be a status, and there's going to be a timestamp. And then the gaining process could know, hey, I'm getting JSON, I'm going to get these things. I can look for request ID and I can expect to find it based on the protocol in the JSON schema.
Okay.
All right. I think that was probably the biggest one. Let's see, module 5. Oh, let's see. This one is the one where we talked about consensus algorithms, where we establish various ways different network nodes can communicate. Primarily talked about um,
Oh,
peer-to-peer.
sorry. One other question.
Absolutely.
How much, how much is protobuf, are protobuf questions on the exam, or how much do we need to know about protobuf?
Um, I would say if you can, I have a good reference. If you can recreate something that looks like this,
So,
you probably are good.
hmm,
The most important things are probably the understanding of like what is it? It's an abstraction. Obviously, this is module 6, but it's an abstraction of some of the network layers from the OSI model, and it allows more complex interact and scalable options.
Real quick, since you mentioned Module 6,
Yep.
um, do you know like how much will necessarily of Module 6 be on the exam? I know our exams moved So sometimes like less of a module that's the last week will be on an exam, but
Yeah, I know what you're talking about. As far as this one though, I haven't seen the test, so all I have is my memory from fall, I
right.
think, of last year, going through it. I don't remember much from Module 6, but I don't want to like I don't want to lead you astray. I have no idea. I know Dr.
Well, I know
Milhez updates classes a lot.
This is the first C session, I think,
Yep.
for this class in online.
So right now we're actually we have students from the B session and the C session in here
Oh,
right now.
okay.
But you're right. It should be the same test for everybody though.
Okay.
It should be the only timelines should be the only difference.
Okay.
Um, what would be some of the advantages or disadvantages of having a distributed system with all peers versus having a leader and a bunch of
Workers.
worker nodes? Thank you. Yeah.
Um, the peer-to-peer um is not a majority vote, and any peer can take information. Um, leader
So,
work.
sorry, go ahead.
Go ahead.
So somewhat peer-to-peer has the benefit of there's no single point of failure. If one peer drops off, and with distributed systems, kind of the golden rule is you have to expect things to fail because you might have 100 nodes. If six of them go offline because of a thunderstorm or someone flipped a switch, the whole system can't crash. That kind of defeats the purpose of having an awesome distributed system. So peer to peer, you have to care about things like leader election. The Raft algorithm was an example I think that was mentioned in the chat. In fact, I can't remember if it was assignment 5 or 6. We actually created a leader election application. But peer to peer has a lot of benefits as the leader could swap. So any peer could take over the leadership position, and there's lots of ways you could decide who becomes the leader, that kind of thing. But if you have a leader established, you get a lot of power for you have a single point where which can control how everything works. The leader's usually better able to organize the peers to complete whatever task it needs to. But if the leader goes down, well, then the whole network is offline until the leader comes back, or maybe a new leader is assigned. So peer to peer is a bunch of equal operations working together, whereas a leader is you could think of as like the conductor, and they are primarily used to deal with distributed algorithms. That actually ties very well into parallel versus sequential, because if you have a task, if you can split it up into multiple pieces, that would be an excellent time to use a distributed system. Whereas if every step basically relies on the step before it, that's not likely to um, split into multiple processes very effectively because they're going to have to keep communicating. The leader is going to have a lot of coordination to do, and you're probably not going to get much benefit from having a distributed system.
So
So,
this was
go ahead.
confusing when we did the lab because well, it wasn't confusing, but I just want to make sure I understand. So if you do lead, we did a election where we just clients voted based on an answer to a math question. But
Yep,
in reality, if you look at Raft, this is leader election. So these clients would have to be peers in order to switch to become a leader if the election elected them.
exactly.
But we didn't make them peers.
We
So, oh, sorry, go ahead.
I was gonna say in that assignment, I don't we weren't meant to like implement like a leader election system. It was just meant to be straight up leader and workers. We weren't doing a straight peer-to-peer system.
I know,
Exactly.
but my point is that, but we were doing kind of halfway because we were creating an election process. So
I,
if you wanted to go the whole way, then it would be all the programs would be the same essentially. They would be able to be a client or a leader.
Yes, but we didn't really do that portion
We just
because
automatically assigned a leader.
precisely.
yeah, so the voting with the consensus rounds, that wasn't from my understanding, that wasn't a leader election. We were just doing some kind of uh unrelated voting.
Yeah, if we wanted to do what you were saying, we would not have had a leader.java class. We would have had to have just workers, and that would have been personally, I think that would have been much more challenging. I think it's kind of nice we only had to worry about the consensus part because speaking for myself, that was confusing enough on as it is.
Yeah.
But the
If
consensus is the voting portion, and with a leader to coordinate, it kind of makes the whole process a lot more streamlined.
if we did the leader having to be picked, it would have been something closer to the example peer-to-peer um code given, but we would have had to like add a bunch for a leader.
Yeah, it would have been pretty tricky. So hopefully that kind of explain leader election and consensus is two separate concepts. Because you pretty much always are going to need, I don't want to say you always need a leader. I can't imagine a scenario where you wouldn't need a leader, but I mean, maybe there's something out there. I'm sure
Our
there's something.
peer-to-peer example didn't need a leader, and that was just the peers saying hi to each
Oh,
other or whatever.
yeah, they're just like distributing the same information to everyone. That's a good point. Yep. They're just like blindly, hey, I get this message. I'm going to let everyone know about it. Yeah, you're right. That's a good example.
Yeah. And there's no voting to be like, is this the correct answer? What's everybody's thoughts?
Yep.
Like, I would see leader and worker being, let's say, since we're all like working together right now on this exam review, if the majority people gave one answer, but one person didn't give an answer, if we were taking the exam this way, it would be the majority of people whose answer we would pick, like if we all shared an exam.
Exactly. That does mean that because I believe there was a mention in the curriculum talking about how consensus algorithm is how security is handled for cryptocurrencies or at least Bitcoin. And that kind of makes sense because if I wanted to put in a node that says I'm actually a billionaire, the rest of the nodes would have to be like, yeah, we don't agree on that, so I'm not. But otherwise, you could have all kinds of shenanigans. At least that's how I understood it. But that was one of those like optional reading things that isn't really related too heavily or super critical. Um, what would be an example of a task that would be ideal to use in parallel? So basically split up into many small tasks and done by a large group of distributed nodes.
Maybe if like everybody was told, create a recipe and add the shopping list to the cart. Or maybe some people would be like, oh, I'll just do my shopping list and then from there I'll create my recipe with what I have.
Okay. I mean, I'm sure there's some. To me, that jumps out as a good example for sequential, to be honest, because the
Yeah.
information of what you bake is based on what you have in your cart. Whereas Something that might be easy to put in parallel would be like maybe a sorting algorithm. Like, hey, we have 1 million things to sort. One thread can take, well, each of 10 threads can take 100,000 items or, whatever numbers you want, and then can sort their sections, something like that.
But
Or,
then wouldn't they all have to come together after that
yes,
too?
the leader would have to um the leader would have to like figure out how that works. Honestly, that would probably work best in the oh gosh, I don't remember the name of it. The sorting algorithm which uses recursion to break everything down into a list of
Merge
one.
sort?
Merge sort maybe?
I think so.
I
But
think
wouldn't
that's like the stereotypical example for parallel processing.
Uh,
but isn't leader and worker required to have like a vote?
So that's only for consensus. So there's
Uh,
consensus is like when you're all trying to decide the answer for something. There's another form of distributed um, algorithms where you just have a network of, let's say, 100 computers and you have some massive task like processing deep space data for NASA or something. And so
hmm.
they just borrow your computer to work on a chunk of data separate from everything else.
Um, I remember a good multi-threading assignment I did in one of my other classes is where we were given an image. It was a 2D array of pixels, and then we split that up into columns and then shot that out to different threads and then applied a filter to it, and then we shot everything back and kind of put it all together.
Yep. That's a good example. I think that's yeah, I remember doing that. The picture of the dog, we had to make
Oh,
it different colors and stuff.
that's right. Wonder Bread, yeah.
Yes, yes, Wonder Bread.
what we didn't see or the language.
Yeah. Yeah, I think we were doing that class in C for the most part. And then these terms in the bottom right here, these are key things to keep in mind when making a distributed system. They're fairly self-explanatory. Obviously, latency, it's going to take time for data to get from one place to another. So you have to do a lot of uh, understanding that, the data won't be there instantly. You have to wait for it a little bit. Fault tolerance, you're going to have nodes fail, you're going to have processes fail, and the whole community at large needs to keep operating. We kind of demonstrated this in one of the assignments. I don't remember which one, where you're waiting for your workers to get back, and then if after a certain amount of time, you just have to decide, okay, well, we've waited X amount of time. This node is not getting back to me. It probably crashed. I'll go with what I have, kind of thing.
That was
Consi
assignment 5.
okay, perfect. And then consistency, you want all the nodes to be able to handle tasks that they're given. Preferably, they'd all be the kind of the same kind of node, and the leader can understand how will the node behave, what kind of input will it take, that kind of thing. And scalability, honestly, like if you're a company and you have, a data center, well, it would be nice to be able to have a system designed so if you happen to build a second data center, you can just seamlessly make use of all your new resources. So that's where you'd want to not be like, in our example, hey, I need three, but if you hard code that I'm looking for three workers before I start, you might not be able to take use of another 1,000 that get added later on, that kind of thing.
So out of code easily.
Yep. These are just things to think about when engineering a system that might have to scale up or scale down, depending on anything, really. So we talked about nodes, we talked about consensus algorithms, talked about distributed systems, even though I didn't put that on the slide, I probably should have. Parallel versus sequential tasks, whereas parallel can be a big task can be split up into little tasks and then worked on piecemeal by many nodes. Sequential is where typically each step really relies on the step before it. So it's a lot harder to split it up, or you might not even be able to split it up at all in a meaningful way. And we talked about the key, I forget the word that they use, key terms basically, when it comes to designing distributed systems. And I have a whole list of questions here, but I think we talked about absolutely everything on this list already. Yes, we certainly did. All right. Is everyone good to move on to Module 6?
Yep.
All right. So Module 6 is basically where we got to see, oh, all this work we've been doing for the last like 6 or 7 weeks. Wait, I don't need to care about any of this. I can just use gRPC and skip it all. This is amazing. Honestly, there's not a lot of talking points on this module. Where is that here? Yeah. So it's mostly focused on protobuf, which is this format here. It's type safe, so you have the string, movie rating, um, int32, kind of a C style stuff. String is lowercase instead of uppercase. Maybe a blurb from here of like, repeated string int32 float bool kind of thing to jog your memory. If you don't feel super confident you can remember this, you'll probably have to write some small proto thing. I don't know for sure. I know I did. That was one of my test questions, was write a small protobuf protocol for some scenario they gave. Um, Key things to remember is just like repeated is an option, and repeated, and then object type, and then something, whatever name you want, or key, I guess you would say, and then just sequential numbers separate on each item, and then the syntax proto3 at the top. Um, yeah, like what is middleware? We already know it kind of abstracts away a lot of the stuff that you as a developer need to make. There's more overhead at the top, but if you're making a really complex system, you're probably going to want this as opposed to having to handle every single message with JSON or XML or something else. Um, what's what would be a disadvantage of middleware? So a disadvantage of middleware is there's a performance overhead. You have to use a framework. I think the term is correct. Framework of like gRPC. They mentioned briefly, though we didn't really go into Apache Kafka. I've never used that. RabbitMQ and Redis. Heard about those, but I've never used those personally. You're not going to have to know those, of course. gRPC is more than sufficient. On screen now is kind of the format that we used. I seriously doubt you'd have to memorize this. Um, but I mean, if you have extra space, I guess it couldn't hurt. But it's basically using what is essentially not essentially, it is a build pattern to just sort of put together a response, and you call you do network actions much like you would call a function in another class. RPC actually specifically, I think, stands for remote procedure call. And the G for gRPC is just because what we used is Google's variation of it.
The
Actually,
remote procedure call.
yep, remote procedure call. And actually, design benefits, I won't even bother asking because they're right on the screen here. We have security, efficiency, it definitely uses binary, which makes it faster than what we're likely to use. Because let's be honest, if we're building this ourselves, I would probably be inclined to use something like JSON because then I can read it and debug it easier. But here, it's always binary. And then fault
Um,
tolerance, I don't think we did anything with fault tolerance as far as gRPC, but it is listed as one of the benefits.
what's the G stand for?
Google, just the company.
Yeah.
And what's down here? Oh, this is a review session like planning document that someone came up with many semesters ago. I kind of just use as a baseline, but this is what it says, our key exam tips. We went over all of this, I believe, TCP versus UDP. We talked about blocking, synchronized, the world's greatest keyword for concurrency. We didn't really talk about buffered versus unbuffered streams. So when you have a socket, you have what that's going to send is byte streams. And then you're going to have a stream reader that turns it into characters. And buffered reader and buffered writer give you functionalities like read line. So you can kind of iterate through the data much more efficiently. It also allows you to transfer data faster, although I don't know specifics of how that works, but those are kind of the key elements of like socket gives a byte stream, reader gives characters, buffered reader, buffered writer give fast, easily parsable data that can be controlled through JSON. Consensus, we talked about that and how, like in our implementation of a consensus algorithm, we went with 50%, but you can decide that for yourself. It doesn't have to be 50%. It could be 70% or whatever, um, whatever you want, really. And parallel versus distributed, we talked about that. This is other definition. Parallel equals cores, distributed equals machines. I mean, you could also distribute something like between cores, but okay. Um, Middleware, abstracting network complexity, and gRPC. Cool. Does anyone have any questions on anything we've covered here today?
No.
Cool. Well, we've touched on every topic that could be on the test, so you should be in good shape. Depending on which class you're in specifically, I don't remember the dates for all the exams. But they should be upcoming very soon. So
B session, last day of class. C session is Sunday through Tuesday, I believe.
okay,
There's announcements.
nice. Okay, yeah, that makes it simple. Cool. All right. Well, in that case, I'll end the video, but I'll still be in Slack if anyone has any other questions they want to message, and I'll kind of add it on there. I'll work on compiling this video, which I imagine will take a fair minute, and then I'll get that posted in the Slack channels. And then we have a question. I'm going to ask the instructor if she has. I think we kind of figured out schema versus protocol ourselves, but I'll just see what she says about it. She might have a better explanation that makes it more clear. So if there's nothing else, have a wonderful Monday and good luck on the test.
All right, thank you. Bye.
Thank you.
Thank you for the review, Christopher.
Absolutely. Thank you.
Thank you.